is the very most basic elements of the instruments that we make, and really almost all modular synthesizers. There's certain basic elements that you'll see throughout any and every system, and that's what we'll talk about today. So it starts with signal generation, and in our system that's the DPO. And with the DPO you can create very simple waveforms that you can then further process in other places of the system. So you get a signal here. I'm going to turn it up slowly, Rich.
Okay.
I'm full blast now. Okay, turn it down a little bit. There we go. All right. So I guess it's kind of rough for you guys at the edge, but you can get an idea of what stuff looks like too. Let's go. Maybe move it back a little bit for you. That gonna work? I don't know if they'll be able to see it. But the DPO makes very simple sounds. Triangle wave, sine wave, saw wave, square wave. So those sounds, as a starting point, are quite simple, and you probably want to do something else to them, but for what we're talking about today, they'll be good. Unlike a lot of keyboards and stuff that you have around, you don't have keys that you can just play through the basic notes of the Western scale. Instead, you have a continuous pitch control, so you can go from something that's almost subsonic all the way up to something that's almost supersonic. Once you have this sound going, though, you're probably going to want to turn it on and off at some point. You don't want to just hear it the whole time. And for that, you use something like a VCA, something that turns the sound on and off. Kind of like the level control in your mixer. At this point, it's still not really super interesting because you're saying, well, what's the difference between that and just plugging a test tone into my mixer? The difference is that we have also control signal generators. And what they do is they make signals that control these parameters like pitch, sound level, and a lot of other things. And control signal generators come in a few different flavors. In this system we have the math, which makes really predictable voltages. Stuff that goes up and comes back down, and it does it the same way each time. And you can dial it in to be taking as short a time or as long a time as you want it to. I think maths will do up to 25-minute cycles. So it also will go up into the audio range, so from like 1 kilohertz to 25 minutes. Quite a wide range, and plenty enough for most musical purposes. So with something like the maths, we could turn that sound on and off. Still pretty simple, but hopefully you get the idea of what the control signal does versus what the audio signal does. The audio signal is making that continuous tone, and the control signal is turning that tone on and off. The control signal can also come from other places in the system. For example, we also have something that generates random voltages. Random voltages are exactly what you would probably guess they are. They're random voltages. They're highly unpredictable. There's small ways so you can sort of guide them in the direction you want them to go, but for the most part, you have no control over them, hence the name random. I'm going to show you random voltages passed into the pitch control of the DPO because it's really easy to hear their effect. This top jack here is for stepped random voltages. So those are going to be very sharp changes, almost like a staircase. So they'll look stepped. So we'll patch that into the pitch control input here for the DPO. And what you hear is random pitches. Now you can change that random to some degree. For example, you could change the rate of it. And you can make the sounds of computers exploding. so it doesn't change really suddenly. And that's this second jack here. We'll listen to what that sounds like. So the stepped random voltage, that's pretty wild. Compared to the smooth random voltage, a little tamer. Oops, there we go. So you've got your highly predictable voltages from maths. And we'll do that on the pitch tubes. Your random voltages from something like the woggle bug. And then the last type of controller we have is sequential controllers. That's these modules down here, the pressure points and the René. Well, keep in mind that there's obviously a lot of variations on these two themes, you know, random voltages and the more predictable linear voltages. These aren't the only two ways to make those things happen, but I think they're good examples of it. Sequential voltages, on the other hand, are something that you program sort of in the same way that you program a sequence into your computer or something like that if you're using a digital audio workstation. You select notes using these knobs, and then you attach a clock source into it to give it some timing reference, and away you go. So, for example, we could take a clock. I already have a clock coming here from this maths, and attached in here, and you can see that it will start stepping through. I don't know if you all over there can see that. But you can see it starts stepping through these different locations. If we pass the output from this sequencer into the pitch control of this DPO, the net result will be a sequence. To change that sequence, we would select a stage and choose the mode. So most of the time with sequencers, people use them to control the pitch, but you can use it to control anything. For example, you could use this same sequencer to control amplitude. You can use the same sequencer to control some other parameter in the synthesizer. That's like sort of the thing that differentiates a modular synthesizer from your typical keyboard synthesizer, is that even though everything sort of has a design purpose, the main idea is that you can use it for any purpose. Just because we said, oh, well, this output here is designed to drive the pitch control of VCO, that doesn't mean that's where you have to use it. You could use it anywhere in the system that will accept the control voltage. So if we put a couple things together here, we have a sequence going. Actually, we'll patch it into the pitch. Then we could take something else to control that amplitude. And in this case, this sequencer also generates gates, which are a timing signal. And we're just going to use those gates to open and close the sound level on this VCA. And then we can bring some random voltages in there. Have them modulate something else, like, for example, maybe the pitch of the clock. Signal paths in a modular synthesizer. You've got your control signals telling things what to do, and your audio signals making the actual sounds. When you talk about sounds, we can go from that simple sine wave that you heard earlier And we can take that and we can shape it into other kinds of sounds. For example, on the GPO, we have some shaping and wave folding and whatnot that makes the sine wave a little more interesting. So wave folding takes that sine wave and folds it over on top of itself, so it adds harmonics to the signal. Wave shaping basically uses a few other shapes that are coming off the core of the oscillator, and can make the sound thinner or buzzier. And then we can start modulating those and really animate the sound. But just because you start with that simple sine wave doesn't mean that's what you got to live with. You can take it any direction that you want to. But a lot of people actually do use just straight sine waves too. When you start combining different frequencies of sine waves, you can get really beautiful sounds. Another thing that people like to do with modular synthesizers a lot, because there's a lot of analog oscillators and a lot of patch points, people really love to do frequency modulation. And that's another way to take that sine wave and make it sound more complex. We also do some digital modules, so you can take that sound and apply DSP processes to it. For example, pitch shifting and echo. So if we took that sine wave that we were folding and making sound really complex, and then we could apply, say, for example, some echo to it. And also pitch. So we started with that sound, and we ended with this sound. It's, I guess, an introduction to modular synthesis. I don't know, folks, honestly, it's such a deep subject. I don't feel like I could really tell you enough in 40 minutes or even 40 hours. I think in the end, it really it requires you to have the interest to actually poke in and figure out what it is about these processes that interest you and how you would use these instruments in what you do. And I think that's why a lot of people are very attracted to modular synthesis, and at the same time, I think it's why a lot of people are very uninterested in modular synthesis. There's a lot of really easy ways to get crazy sounds these days with iPad apps and all of these and all software synthesizers and whatnot. I think the modular synthesizer presents a completely different way of getting into some of those deeper sound processes. And if you're attracted to doing things with your hands and experimenting in a very physical, tactile way, then this is exactly the kind of thing that you will be interested in. If you're more looking for something that will create results immediately, then you will not be interested.